generative AI's true, often underestimated power isn't merely mimicking existing data, but genuinely understanding its underlying statistical structure. It adeptly maps complex information into rich, continuous latent spaces, representations far more nuanced than simple categorization. Think of a latent space as a hyperdimensional canvas, where similar concepts are inherently grouped as neighbors. Moving smoothly, even subtly, through this space creates gradual, sensible, and often surprising transformations in the generated output. This isn't just interpolation, it's meaningful navigation. Diffusion models powerfully exemplify this principle. They learn to meticulously reverse a predefined noisy process, incrementally denoising what begins as pure random data into stunningly coherent images or intricate text sequences. This iterative refinement builds profound complexity from elemental simplicity far beyond mere sampling from observed data. Consider its impact in accelerated drug discovery. Generative models like IBM's MegaMolBART can propose entirely novel molecular structures, precisely tuned with desired pharmacological properties. They intelligently navigate the vast chemical latent space, identifying viable compounds not yet synthesized, dramatically accelerating the research and development pipeline. This approach stands in stark contrast to earlier generative adversarial networks, or GANs, which frequently struggled with issues like mode collapse or unstable training dynamics. Diffusion models offer superior sample diversity and remarkable training robustness, because they don't pit two competing networks against each other, but learn a direct, robust mapping from a noisy prior to the target data distribution. While the sheer compute demands for training the largest diffusion models are often highlighted, a crucial lesser-known fact is their surprisingly efficient inference once trained. This has paved the way for smaller distilled versions now emerging, enabling their practical deployment on edge devices and integration into popular Python libraries like diffusers, effectively democratizing access far beyond the purview of cloud giants. Ultimately, generative AI, especially through sophisticated latent space exploration, doesn't just expand our creative tools, it redefines the very act of creation itself. It profoundly shifts our focus from programming explicit rules to cultivating sophisticated digital artists and scientists that in essence learn to dream.